Okay, welcome back yet again. Here in this video we are going to talk about multiplying, simplifying, and applications, and all of these are going to deal with, you guessed it, fractions. Okay, fractions seems to be the name of the game, and so fractions we are going to have loads of fun with. Now specifically what we're going to look at is some tips and tricks on methods to be able to work with and reduce fractions, create fractions in ways that are a little bit, say, easier than playing just straight old guess and check. And so let's just go ahead and get to it. So the first thing we're going to look at is we are going to look at some different examples of simplifying fractions. Now, simplifying fractions is one of the single most important parts to fractions. No matter what you do, no matter what answer you always get, you always have to look at that fraction and ask yourself, can I simplify this any further? The reason for that is because in math, we want the smallest possible answer that you can come up with. And the way we achieve that is by reducing everything down as low as they can go. Okay? The smaller the numbers, the easier to work with, and so that is one of the reasons why we do the whole simplifying game. So, how to do it? The fastest way to simplify fractions is to look for the largest common factor between your numerator and denominator that you can find. Now, you may be really good at finding common factors, and then more power to you. But if you're somebody like me, who even though I love math, sometimes you got to work at it, a common denominator, or common factor, is just as good as finding the largest common factor. Okay? The difference is you may just simply have to simplify through common factors more than once. And so that just kind of depends on your ability to find them. So, let's look at our first fraction. I've got 42 over 48. So to find a common factor, one of the ways that I see a lot of students attack it is we look at 42 and 48 and we literally list out their factor trees. Okay? So if we look at 42, we can look at its factor tree. So first and foremost, we know good old-fashioned 1 and 42. So then if you keep going, we've got 2 and 21. We've got 3 and 14. And then we have 6 and 7. So again, notice that 6 and 7 are very close to each other. And so therefore we're kind of reaching the end of what we have. And so that's just the first. Well, I also have to look at 48. Again, I can do the same thing. I know that I have 1 and 48. I know that I have 2 and 24. I have 3 and 16. I have 4 and 12. And then I have 6 and 8. So if I actually look closely at this, I can identify all of my common factors. So if you notice here, I have a 1 on this side, I have a 1 on that side. I've got a 2 over here, I've got a 2 over here, I've got a 3 over here, I've got a 3 over there, I've got a 6 over here, and a 6 over there. But then, if you look at the bigger numbers, notice I have no others in common. So if you pay attention to these, I actually have 4 different common factors I could use. And using any of these common factors will work. What's going to get you the biggest bang for your buck, i.e. is going to make sure that you have finished the problem faster than anything else, is going to be used what's called the greatest common factor. And in this case, that would be 6. So here, my greatest common factor is going to be 6. So what do I do with that 6? Well, I have to take my 42 over 48, and I have to divide out that 6 from both top and bottom. And that is going to reduce my fraction down as far as it can go. Well, here's the cool thing. Because of my factor tree, I already know if I take a 6 out of 42, I'm left with 7 on the top. And if I take a 6 out of 48, I'm left with 8 on the bottom. And if you look at this fraction, notice 7 and 8 are not going to reduce with each other anymore. Therefore, we know that we have found the smallest, most simplified fraction. Okay, pretty simple. Now, as a point, if we had, say, you started out with 2, well, then what would happen is once you divide it out by 2, notice you would be left with 21 over 24. If you look at those 2, you then would have to create a new set of factor trees. You would look for the commonness between them, and you would have to divide again. So if you don't divide by the largest common factor, it will still work. It just means you're going to have to do extra steps. And I know in the world of students, having to do extra steps on math is not something that we all get excited about. So as long as you strive to try and find the greatest common factor, the less steps you're going to have to do. And using these factor trees is one of the fastest way to do it. Okay. Now, I have 9 and 36. So I can do the same thing. I can look at 9 and I can create its factor tree. So I've got 1 and 9, 3 and 3. Pretty simple. Well, now I've got 36, so I need to do the same thing there. So I've got 1 and 36. I've then got 2 and 18. I have 3 and 12. I've got 4 and 9. And I have 6 and 6. So again, I want to look at what are my common factors that I have between this. And so here I have a 1, I have a 1. Then if you look, I have a 3, I have a 3. I already did 3, so I'm not going to do it again. But then I have a 9 and I have a 9. So if we're looking for what actually is my common factors, in this case I have 3 of them. However, my greatest common factor happens to be 9. So for this problem, that GCF here is 9, which means I'm going to take my fraction 9 over 36. I have to divide top and bottom by 9. So 9 divided by 9 gives me a 1. 36 divided by 9 gives me a 4. Okay. Now, let's look at a fairly big number. Okay. So here I have 300 divided by 2,250. So let's take a look at that. I have 300 divided by 2,250. Now those seem like some awfully big factor trees. So before I get to my factor tree, I'm going to take a look at my numbers, and what do I notice? Well, I notice both my top and my bottom end in a 0. And I have a divisibility test that covers that. If I divide by 10, in order to do that, says that my number has to end in 0. Well, these do. So the very first thing that I can do is I can say, okay, I'm going to take my 300 over 2250 and I'm going to divide it by 10 and see what I get. So 300 divided by 10 leaves me with a 30. 2,250 divided by 10 leaves me 225. Much better factor tree for 30, not so much of a better factor tree for 225. So again, I'm going to take a look at it. Now I have a test that covers this. If you remember, a test for divisibility, if we want to divide by 5, we have a rule. And that rule says the number has to end in either 0 or 5. Well, in this case, I have a 0, I have a 5, so I can use my divisibility test. So I'm going to go ahead and take that 30 over 225, and I'm going to divide top and bottom by 5. When I do that, 30 divided by 5 gives me 6. 225 divided by 5 gives me 45. Now, in looking at those two, much better factor trees. If I look at 6, this breaks into 1 and 6, 2 and 3. If I look at 45, this breaks into 1 and 45, 3 and 15, 5 and 9. So again, I can take a look at what I have in common. So obviously here's a 1, there's a 1. I have a 2 here, but not here. I have a 3 and a 3, and that's it. So when I'm looking at my greatest common factors, my GCF in this case is going to be 3. Therefore, I'm going to take my fraction, so 6 over 45. I'm going to divide it now by 3. So 6 divided by 3 gives me a 2. 45 divided by 3 gives me a 15. And that is as small as it goes. Okay. So this one here would be an example of taking a fraction and dividing simply by something common, not necessarily by the greatest common factor. Okay? So as you can see, it works either way. It just depends on how many steps you want to accomplish. Okay? So now that we have all of that under our belt, we can actually get into some of the nitty-gritties of doing the actual math, which is to multiply. Now, multiplying fractions says the first thing you want to do is you want to look at both fractions and you want to make sure that your fractions are reduced as far as they can go. Once you do that, you need to find common factors for any numerator or denominator pair, meaning they can be vertical up and down, or they can be diagonal top to bottom. Okay? What they cannot be is top to top or bottom to bottom. So once you get all of that done and you reduce things as far as they possibly can go, you will then carry out your multiplication step, which says straight across the top, straight across the bottom. So when I'm looking at this, my first one, I have 4 over 6 times 1 over 6. The first thing I want to do is I want to, again, check to see if I can reduce. So I'm going to look at 4 over 6. Well, that one's pretty simple. Both 4 and 6 are even. So automatically I know that I can divide 4 over 6 by 2 and get a reduced fraction. So 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. So I actually have a new equation to work with. I now have 2 over 3 times 1 over 6. So if you think about it, the very first thing that we did was we looked at this vertical fraction and we simplified. Okay. So now again, if I look at my vertical fraction here, I can't simplify any. If I look at my vertical fraction here, I can't simplify any. If I go from my right top and my left bottom, I can't simplify any. But if I look at this fraction here, notice I can simplify that. So I need to simplify again. So in order to simplify again says that I'm going to look at 2 over 6 and I'm going to reduce them. Well, I already know 2 is going to go into 6 3 times. So to reduce it is as simple as this 2 will become a 1 and this 6 will become a 3. Thus changing my fractions again to being 1/3 times 1/3. Now that both of them are reduced, you are going to multiply across the top and across the bottom. So in other words, my new fraction is going to be a single fraction. I'm multiplying across the top, so 1 times 1, and I'm multiplying across the bottom, 3 times 3. Actually do the math here. 1 times 1 is 1, 3 times 3 is 9. And this is my overall result. Okay. So let's work another one. So here I've got 25 over 12 and 18 over 35. Okay. So if I look at 25 over 12, I don't really see anything in common there besides 1. 18 over 35, kind of the same thing. So I need to start looking crosswise. So I have 25 over 12 times 18 over 35. So the first thing that I might look at is I might look at top left to bottom right. So I'm going to look at these two right here, and I have to simplify. So in order to simplify, again, we need to look at what's in common. Both of these end in a 5, so I already know that I can divide a 5 out of both the top and bottom. Take a 5 out of 25, and that's going to leave 5 behind. take a 5 out of 35, and that's going to leave a 7 behind. So this means my new fraction is going to be 5 over 12 times 18 over 7. Well, 5 over 7 is reduced as far as it can go. 5 over 12 won't do anything. 18 over 7 won't do anything. But 18 over 12 will do something. So here again we need to simplify. So if I look at 12 and 18, I know for a fact that 6 goes into 12 and 6 goes into 18. So if you can't see that right away, then one of the things that you would definitely want to do is go back to what we did during those first 4 examples, which is create those factor trees and identify your common factors. However, I know in this case that I can pull a 6 out of both. So when I pull a 6 out of 12, I'm left with a 2. And when I pull a 6 out of 18, I'm left with a 3. So in doing so gives me a new fraction. This is 5 over 2 times 3 over 7. So look at it again. 5 over 2 doesn't reduce, 3 over 7 doesn't reduce, 5 over 7 doesn't reduce, 3 over 2 doesn't reduce. So at this point, we now can multiply. So remember, you want to multiply across the top and across the bottom. And then look and see if you can simplify one last time. Okay? So again, we're going to have one single fraction. Multiply across the top says I'm going to do 5 times 3. Straight across the bottom says I'm going to do 2 times 7. If I multiply those, 5 times 3 is 15. 2 times 7 is 14. If I were to compare 15 and 14, nothing reduces. Thus, I have gone as far as I can. Okay. Alright, let's look at another one. So here I have 18 times 5/6. So I have 18 times 5 over 6. Well, one thing that I have to remember here is that any whole number is the same thing as saying that it's over 1. So you can go ahead and input that into your equation if you need to in order to help make things a little easier. Now again, I need to try and simplify. 18 over 1 won't do anything. 5 over 6 won't do anything. However, I already know 18 over 6 will do something. So I have to simplify these two numbers. I know that 6 goes into 18 nicely. So when I'm doing that, 6 divided by 6 becomes a 1. 18 divided by 6 becomes a 3. Thus, making my new fractions 3 over 1 times 5 over 1. In looking at them, they don't reduce any further, so I'm going to go ahead and do my multiplication step, which says 3 times 5 all over 1 times 1. This is going to give me 15 over 1. But remember, we have a rule, and that rule says any number over 1 is the same as that number. So therefore, I have to take this fraction one more time, and I have to simplify. So in order to do that, it says simply apply that rule. 15 over 1 is going to then become 15 as the result. And thus, that is the answer. Okay? Now, let's look at a couple that have some really big numbers. Alright, so I have 56 over 117 times 63 over 128. So, the first thing that I would do is I would look at the fact that I have these two even numbers here. And I would see if I can simplify these. So I have 56 and I have 128. I would go ahead and make your factor trees if you need them, because these are relatively larger numbers. So when I have 56, I already know that I have 1 and 56. I then have 2 and 28. I then have 4 and 14. I have 7 and 8. Okay. Now 128 is going to be a little bit bigger. So I know I can start out with 1 and 128. And I want to go ahead and speed things up a little bit. So if you notice, 56 only has these select few factors. So I'm going to just simply use these numbers and see if any of these pull out of 128 evenly. So I already tested 1. Now I'm going to test 2. So if I look at 128, it's even. So I have 2 and 64. The next thing that I have is I know I can pull out a 4, which is going to give me 32 as a result. I then also know that if I pull out an 8, I get a 16. I can then look at 14 as well as 28 and 56. And what you'll notice is that none of the rest of these actually work. So if we're looking at what we have, we've got the 1 on both, we've got a 2 on both, we've got a 4 on both, we have an 8 on both, which means automatically that my largest here is going to be an 8. So when I pull an 8 out of 56, I am left with 7. And if I pull an 8 out of 128, notice I'm left with 16. So I have to rewrite my fractions to show that I have now 7 over 117, and I'm multiplying that by 63 over 16. Now, here's where I see a lot of students struggle. We look at these two odd numbers and we automatically assume, oh, they can't have anything in common. If I were you, when you're working with large fractions, I highly suggest you check. So here we're going to see if we can simplify these two numbers by looking at their trees. So the first thing I'll look at is 63. And so what do we know about 63? Well, I know 1 and 63. I've got 3 and 21. I have 7 and 9. So I'm going to use these 6 numbers and see if any of them come out of 117. So when I look at 117, I know I have 1 and 117. I also want to look at, does 3 work? And in this case, 3 and 39. I then take that 117 and I test 7, as well as 9, 21, and 63. And so here I know at 9 I get 13. And that, I believe, should be it. Now, I don't create the big factor tree for 117 because none of the rest of the numbers matter, as they don't show up in 63. So here again, I've got 1 on both, I've got a 3 on both, I've got a 9 on both. So if I'm looking at it, my 9 here is what I want to divide by. And this is where I see a lot of students struggle, is we make this assumption and then you multiply and get really large numbers and then call it a day, when really we could continue to simplify. And so here we can see that if I pull a 9 out of 63, I'm left with 7. And if I pull a 9 out of 117, I'm left with 13. Thus, making my fractions 7 over 13 times 7 over 16. So now I can go ahead and multiply them. So here again, I'm going to multiply straight across the top, so 7 times 7, and straight across the bottom, 13 times 16, which is going to give me the reduced fraction of 49 over 208. Okay. Alright, now I wanted to do another big one, and so let me grab a sheet of paper here. And we are going to look at 234 divided by 375, and we're going to multiply this by 450 divided by 207. So, let's go ahead and get started. Okay. So we got some pretty big numbers. That's okay. We're just going to do the same thing that we just did on the other 4 problems. First and foremost, start with the simple one. My bottom fraction ends in a 5, my top fraction ends in a 0. So I automatically know that I can simplify this fraction. And I can do so by pulling a 5 out, for sure, to start with. So I'm going to go ahead and know that those 2 are going to cross out, and I'm specifically just going to look at that 450 over 375. Okay, if I divide this by 5, then once I do that, 450 divided by 5 is going to give me a 90 on top. 375 divided by 5 gives me a 75 on the bottom. Now look again. I have a 0 and a 5, which means I can actually divide by 5 one more time. If I take 90 divided by 5, that's going to give me 18 on the top. 75 divided by 5 gives me 15 on the bottom. If I look at 18 and 15, one thing that you should notice is that both of these can divide by 3. If I do that, I'm left with 6 on the top, and I'm left with a 5 on the bottom. So when we're talking about our big overarching fraction, when I have 450 over 375, that actually is going to simplify all the way down to 6 over 5. So that leaves me with the 5 in the bottom here and the 6 in the top. Okay. So if I go ahead and rewrite it, that means I now have 234 divided by 5 times 6 over 207. Now the next thing that I want to look at is will these two simplify? Okay, which is my goal. And so in order to do that, again, I need to look at my numbers. And so here I can make my factor trees, but these are relatively large. Okay. So let's go ahead and get started. I have 234 and I have 207. So usually the smartest thing to do is to start with the smaller one, so we'll go ahead and do that. So I have 207, and first I know I have 1 and 207. I also know that I have 3 and 69. I also have 9 and 23. I think that's about it. Forgive me because I have not done this ahead of time. Yes, so that's it. So that actually wasn't so bad. It's only 3 terms. So that means I'm going to look at 1, 3, 9, 207, 69, and 23 and see if any of those come out of 234. So I know I have 1 and I have 234. So the next thing I'm going to look at is 3. And if I take 234 and pull a 3 out, I get a 78. Now I want to look at 9. So if I take 234 and pull 9 out, I'm left with 26. I want to look at 23. So I have 234, pull out a 23, and that gives me a decimal. 234, pull out a 69, also gives me a decimal. So again, fairly simple. I've got 1, 3, 9, and 1, 3, 9. If you look, my 9s are my greatest. And so here, when I pull a 9 out of 234, I am left with 26 on top. And on 207, I can pull a 9 out and I'm left with 23 on the bottom, thus giving me a new fraction of 26 over 5 times 6 over 23. I now want to go straight across the top, so this is going to be 26 times 6 over 5 times 23. And in this case, this is going to give me 156 over 115. And that is my end result. Okay. Now the very last thing I want to look at, because I know this is getting a little lengthy, is I want to just quickly show you a couple of applications and how to best attack them. So if you can bear with me for a few more minutes, if you're getting bored with the sound of my voice, then go ahead and pause the video. But I just have a couple applications that we're going to look at so that you have a little better understanding on how to attack these big giant story problems. that you may or may not be given. So, first and foremost, when attacking application problems, you have to be able to identify the key ideas or which words in your problem might mean multiply. You also have to be able to take your word problem and create the multiplication of your fractions in order to solve for the correct answer. Okay? So here we have a recipe calls for 3/4 cup of flour. You want to only make half of the recipe. How much flour should you use? So in this case, what do we know? Well, we know that we are starting with 3/4 cup of flour, and I only want to make half, okay, of the recipe. So right here, this is signifying that you want to multiply. So we have to multiply our 3/4 by 1/2. So first things first, again, we want to look. 3/4 does not reduce, 3/2 does not reduce, 1/2 does not reduce, 1/4 does not reduce. Therefore, we can simply go ahead, create my fraction, so straight across the top and straight across the bottom. So this becomes 3/8, thus answering your question. Now, because this is a word problem, in the general we have to add our units onto it. We were talking about cup of flour, therefore this would be cups. Okay. Alright, let's look at another one. We have sociologists have determined that 2/5 of the people in the world are shy. A sales manager is considering 650 people for an aggressive sales position. How many of these people might be shy? Okay. So here we've got that we are starting with 2/5 of the people in the world are shy, and I want to consider 650 of those people. And so to do that means I need to remember 650 is a whole number, so it's the same as over 1. The other thing that I can look at is I can go ahead and look at doing some reductions. So I have this 650 and 5. Notice ends in 0, ends in 5. So I can reduce that. In doing so, my 650 is going to go away, and it is going to become 130. My 5 goes away and becomes a 1, thus changing this problem to being 2/1 times 130/1, which gives you a total of 260 people. Okay. Now, in terms of problems, that should make a lot of sense, because when we're talking about how many people, we don't generally consider people to be in fractions. So when you're talking about how many people would apply for a job, or how many people does this affect, we're usually looking at a whole number. So if you come out with something beyond other than that, you might want to double check your work. Okay. Alright, last two. First, we have that a pizza is cut into fourths, and then each of these fourths is cut into thirds. What fraction of the pizza is in each of the final pieces? So I am a big advocate for draw a picture of what you're seeing. So, I have a pizza. Yay! And the first thing I know about my pizza is that it's cut into fourths. So that would be straight down the middle, although obviously I don't know how to draw a straight line, and straight horizontally. Now that was pretty good. The second thing it says is that each of the fourths is going to be cut into thirds. Okay, so I have to take a block of 4 here, and I'm going to cut it into thirds. So there's third, there's third. Well, I have to do that to each of them. So I then have, here's a third, and here's third-ish. I then have, here's third, and here's a third, and then here's a third, and here's third. Kind of reminds me of the pizza that we just got from Little Caesars, that when you looked at it, no slices are the same. So the problem wants to know what fraction of the pizza is the final piece. So, what do we know? Well, we are then basically looking at, say, this slice. So if we look at that, the first thing that we did to our pizza is we cut it into fourths. So if I took one slice, I cut it into fourths. The second thing that I did to this pizza is I took that fourth and I went, okay, I'm going to cut it into thirds. So that is going to tell me what my little red slice here is. So I've got ones on top, so again we're going to just simply multiply. Straight across the top is 1 times 1, straight across the bottom 4 times 3, which means here I have 1 over 12. Okay. Now that should actually make sense, because if we were to just simply add up all the slices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we have 12 total slices. And then I want 1 slice. So that goes back to the beginning when we were talking about part to the whole. So in this case, looking at the fraction of the pizza that's in the final pieces, your part would be taking 1 slice away. The whole would be how many slices were we working with, thus you get 1/12. So that's a different way to look at that problem, but this is the math that we're doing here. Okay. Last is kind of one of my favorite examples. And so we're talking about a bicycle trip that is 75 miles in the mountains, and 1/5 of the trip is downhill. So what I will tell you is that this piece here, where we're talking about 1/5 being downhill, is one of the more important pieces of the problem that we need to pay attention to. So first, what do we know? Well, if we're going to draw pictures again, do just that. We have a bike ride, and so we are going a total of 75 miles. Okay, so we can start, say, here, and we're going to end over here, and we went 75 miles. Now, we have that 1/5 of the trip is downhill. So what that means is I have to take this bike ride that I did, and I have to go ahead and cut it into 5 pieces. So I have 1, 2, 3, 4, and 5. So each of these is 1/5. And if you add all those up, obviously 5 of them means 1 full trip. Now specifically, what are we told? We're told that 1/5 of it is downhill. So this first piece right here, say, is going to be downhill. What that means is that the rest of this, so these other pieces here, are considered to be not downhill. But we got all of that and we haven't even read the question yet. The question says, find the fraction of the trip that is not downhill, and then how many miles are not downhill. Well, in drawing our little picture, we have already answered the first part of our question. The first part of our question says we need to just simply identify how much of the trip is not downhill. So if 1/5 of it is, then we have 1, 2, 3, 4/5 is not. So we know that 4/5 is not downhill. Okay, that was the first part. The second part says how many miles are not downhill. So I went 4/5, that says 45, sorry, 4/5 of my 75-mile trip not downhill. So again, remember 75 is a whole number, it's the same as over 1. Again, I would look at my 75 and 5 and I would simplify those. In doing so, you're going to find out that the 5 goes away, and you are also going to find out that the 75 goes away. And so when we divide that 5 out, we end up with 15 left over. And so this actually tells us that we have 4/1 times 15/1. 4 times 50 gives us 60. Since we're over 1, we can leave it off. And we were talking about miles. Okay. Alright, so I know this one was a little bit more lengthy than I intended. I hope that you were able to follow along and that it had all the necessary information you needed to better understand multiplying with fractions. Please let me know if you have any questions by contacting me. And remember, math is indeed bananas. So just keep smiling, ask tons of questions, and have fun with your math. And as always, I will see you next time.